Hello, Joe. So today we are going to study gravitation chapter, class one. This is the 11th topic. So gravitation chapter वैसे तो 11th का है, but ये 12th के पॉइंट ऑफ व्यू से भी इम्पोर्टेंट रखता है, क्योंकि होगा क्या कि जब आप इलेक्ट्रोस्टैटिक्स पढ़ोगे आप 12th में पहला चैप्टर, तो इलेक्ट्रोस्टैटिक्स और ग्रेविटेशन का जो कंसेप्ट है वो ऑलमोस्ट सेम है, सिमिलर. So Newton laws of motion, न्यूटन लॉ ऑफ ग्रेविटेशन जो है दैट इज इनवर्स स्क्वायर लॉ, और कूलॉम्स लॉ जो इलेक्ट्रोस्टैटिक्स का है दैट इज आल्सो इनवर्स स्क्वायर लॉ. दैट मीन्स इन बोथ केसेस फोर्स इज इनवर्सली प्रोपोर्शनल टू द स्क्वायर ऑफ डिस्टेंस between the two masses, or say in case or in two charges. So similarly terms are same. Gravitational potential energy is in this chapter, and there will be say electrostatic potential energy. So all gravitational topic will be changed into electrostatic term, and mass will be replaced by charges, and this minus g will be replaced by some constant k. So in this topic we will study say Newton law of gravitation, which is also called universal law of gravitation, then acceleration due to gravity value g, that which we know its value as say 9.81 meter per second square. Then value of g on moon, which is approx g by 6. Its value is say approx g by 6, g on the surface of moon. So its value is approx g by 6. Then variation of g with height, variation of g with height, then gravitational potential energy minus g m1 m2 by r. Then escape velocity, this velocity is say a velocity to put a body into an infinite distance, into space, outer space, out of reach of earth, so that minimum speed, so that it never returns. So अगर किसी ऑब्जेक्ट को हमें अर्थ से प्रोजेक्ट करना है, रॉकेट या सैटेलाइट या किसी भी चीज़ को अगर हमें लॉन्च करना है, देन वी विल सेंड इट विद द एस्केप वेलोसिटी. एंड इफ सैटेलाइट को अगर हमें अर्थ के अराउंड ऑर्बिट कराना है, then we need orbital speed. Then we will discuss neutral point concept. So this neutral point concept gives a point between two masses where net force is 0. That means at this neutral point this attractive force becomes repulsive force. So change of nature of force takes place. आप इसको ऐसे समझ सकते हो कि सपोज इफ दे आर से टू masses, so there will be a certain point, that is a neutral point, where this first mass is attractive and these two masses are giving say attractive force. Then after this neutral point, these two force will attractive force towards second mass. So that point is called neutral point. Then we will discuss Kepler's laws, gravitational field and gravitational potential. And finally, we will discuss gravitational field and potential relation. So these are topics which we are going to study in this chapter. Right. So let us start gravitation chapter. So gravitation chapter is 11th topic, and in this we see that gravitation gravitational force हिंदी में इसे हम लोग गुरुत्वाकर्षण कहते हैं, राइट. तो गुरुत्वाकर्षण कहने का रीज़न आप इससे समझ सकते हो कि एक अट्रैक्टिव फोर्स होता है ग्रेविटेशनल फोर्स. तो यहाँ पे गुरु एक जो बृहस्पति प्लानट है, सॉरी, जुपिटर, उसको हिंदी में गुरु बोलते हैं. तो जुपिटर का जो अट्रैक्टिव फोर्स है गुरु प्लैनेट का, वो सबसे ज़्यादा माना जाता है बिकॉज उसका मास सबसे ज़्यादा होता है. दैट्स वाई हिंदी में इसे गुरुत्वाकर्षण कहते हैं. तो ग्रेविटेशनल चैप्टर में बेसिकली हमें क्या है, ग्रेविटी के बारे में पढ़ना है, अर्थ का ग्रेविटी. तो यहाँ पर दो टर्म यूज़ होता है, एक होता है ग्रेविटेशन और दूसरा होती है ग्रेविटी. तो ग्रेविटेशन इट रिफर्स द फोर्स ऑफ अट्रैक्शन बिटवीन एनी टू बॉडीज इन द यूनिवर्स. तो यूनिवर्स में कोई भी दो बॉडीज़ हों तो इनके बीच का जो फोर्स ऑफ अट्रैक्शन होगा उसे ग्रेविटेशन कहते हैं, राइट. एंड ग्रेविटी इट रिप्रेजेंट्स द फोर्स ऑफ अट्रैक्शन बिटवीन द अर्थ एंड एनी ऑब्जेक्ट अंडर इन्फ्लुएंस ऑफ अर्थ्स ग्रेविटेशनल फील्ड. Then there is a term free fall. तो free fall is the motion of a body under the influence of gravity alone. तो सपोज एक बॉडी को हम लोग सिर्फ ग्रेविटी फोर्स के इफेक्ट के अंदर उसके मोशन को स्टडी करते हैं तो उसे हम लोग फ्री फॉल कहते हैं. तो सपोज एक बॉल को ड्रॉप किया जा रहा है तो mg विल बी द ग्रेविटेशनल फोर्स बाय द अर्थ ऑन द बॉडी. And other forces say air resistance, wind velocity के कारण जो फोर्स होते हैं या फिर विंड के कारण या एयर के कारण, तो इन सबको हम लोग नेग्लेक्ट करेंगे. दैट मीन्स वी कैन से इन वैक्यूम इफ ए मास इज ड्रॉप्ड और से थ्रोन और से मास टेक्स मोशन देन इट इज कॉल्ड फ्री फॉल. सो ओनली ग्रेविटी फोर्स एक्ट्स. अदर फोर्सेस से इलेक्ट्रोस्टैटिक, मैग्नेटिक, these forces are neglected. So only gravity force, single force. Next we will study Newton's moon test. In Newton's moon test, basically this is a proof of inverse square law. Force is inversely proportional to the square of the distance between the two masses. For this we are taking two masses as Earth and Moon. We know that moon orbit around earth in a circular orbit and its time period is say 27.3 days. So time period of moon, T moon, is say time period of revolution of moon about earth and it is say 27.3 days. So distance between earth center and moon center we are taking as small r. So this r moon is the distance between centers of earth and moon. Its distance comes out to be 3.84 into 10 power 8 meter. Time period of moon, time period of revolution of moon about earth equals to 27.3 days, which is say 27.3 into 86400 second. Then we will take speed of moon as orbital speed, the speed with which moon revolve around earth. So with this speed is called orbital speed of moon, v moon we have written as, and its values will be say distance traveled in a complete revolution, that is say 2 pi r perimeter, and divided by its time period t moon. So this will give the orbital speed of moon. So in next we can see this speed of moon, v as say 2 pi r upon t moon. Then we see that since earth is rotating about earth, moon is rotating about earth in a radius r, so it is performing circular motion, and there will be say some acceleration that is called centripetal acceleration, and this centripetal acceleration is equals to v square upon r. So that centripetal acceleration of the moon here will be say v square by r, and that will be say square of this, that is say 4 pi s square into radius by time period square. So this acceleration of moon comes out 2.72 into 10 power minus 3 meter per second square. So next we will calculate this ratio of this acceleration of moon and acceleration of an object on the surface of our earth, that is say g. So this ratio comes out 2.77 into 10 power minus 4. We again see the radius of earth, the radius of earth as say re, and distance of earth and moon as r small r, at this ratio square. So this radius of earth is taken as 6.38 into 10 power 6 meter. So its value says 6380 kilometer, radius of earth, and distance of center of moon and earth is at 3.84 in 10 power 8. So this ratio comes out 2.76 in 10 power minus 4. So we see that these two ratios are almost same value. So these two ratios are equal, that is say a ratio of accelerations of moon and acceleration of an object near surface of earth. So that ratio comes out re upon small r square. So which is say 1, which can be written as 1 upon r square, small r square, 1 upon r e square. So we can say that this acceleration of moon is inversely proportional to 1 upon r square. So acceleration of an object near the surface of earth, that is say g, is inversely proportional to radius of earth square. This is the radius of earth. Similarly, acceleration of an object, that is say moon, at a distance r, that acceleration is also inversely proportional to the r square. So we conclude that this force of on the moon is inversely proportional to 1 upon r square. So we can see that this gravitational force is inversely proportional to square of the distance. That's why we can say it obeys inverse square law. So this is the proof of inverse square law. So this test is called Newton's moon test. Next, we are going to study Newton's law of gravitation. So this Newton's law of gravitation, the gravitational force between 2 point-side object is directly it gives the force of attraction between 2 point masses. It tells us its magnitude as well as nature of this force. So first thing that this force is attractive in nature. Second point is that this force is a central force. That means it acts at the acts along the line joining centers of the masses. If the masses are say uniform spheres. So it acts along the line joining the masses, and it is found to be directly proportional to the product of magnitudes of the masses of the two masses, and it is found to be inversely proportional to the square of the distance between the masses. So its statement we can write as universal law of gravitation, or say Newton's law of gravitation, as the gravitational force between two point-sized objects is directly proportional to the product of magnitudes of the masses, and it is inversely proportional to the square of the distance between the masses, and it is an attractive force always directed along the line joining the point-sized masses. So these are points which we have to know. That first point is that this force is directly proportional to the product of masses. So if we are taking two point masses, say m1, m2, or say two uniform spheres m1, m2, so this force is directly proportional to product of point masses m1, m2. Suppose distance between these two point masses are say smaller, so this force is also inversely proportional to the square of the distance. Then we combine these two, so this force is proportional to product of masses divided by distance square. So here we have to know that this uniform sphere acts as point size object with whole of mass assumed to be at their centers. So whole of the mass of this sphere is concentrated at m1, center of the masses. So if r is a distance between point masses and f is the gravitational force, then we will equate and we will introduce a constant that is called capital G. So this force equals to capital G times m1 m2 upon r square. So this is called gravitational force. So where this capital G is called universal gravitational constant, its value is 6.67 into 10 power minus 11 Newton meter square per kg square. So its unit we see that this will be Newton, this distance will give say meter square, and these two mass will come down and it will be say per kg square. So this is a value or and unit of this capital G, 6.67 into 10 power minus 11 Newton meter square per kg square. For example, if we are taking say masses of two point masses as 40 and 50 kg m1 m2 and distance between them as 1 meter, then the force will come out capital G value, masses product, and then distance square. So its value will be 13.34 into 10 power minus 8 Newton. So we see that this force is a weak force. So if two masses, suppose two persons of 40 and 50 kg are nearby, then the two persons are attracting each other with the same force, with the same magnitude force, and its value will be very less. Its order comes out 10 power minus 7 Newton. So 13.34 in 10 power minus 8 Newton will be the force. So we can say this is a weak force. So gravitational force is assumed to be a weak force. Now suppose we have to find a gravitational force between a point mass and a continuous mass. Continuous mass, which may be a bigger mass, ring, disk, sphere, etc. And there is a point mass capital M. So there is a point mass capital M, and there is a say continuous mass which is a bigger mass, where dm will be taken as a elementary mass. So this continuous mass is made of several dm. So several elementary mass dm. So all this elementary mass are added to get the total mass m of this continuous mass. So if continuous mass value is say small m, then dm will be taken as a elementary mass. हमें यह ध्यान रखना है कि this elementary mass may be a point mass, and it may be a ring, it may be a shell, spherical shell. In case of a rod, it will be a point mass. In case of a disc, it will be a ring. And in case of say solid sphere, it will be say spherical shell. So dm elementary mass shape may be a point mass, it may be a ring, it may be a spherical shell. It depends on the continuous mass which we are taking. Now df will be taken as the force between this point mass and this elementary mass dm. So this df is will be attractive force, that is this dm will attract dm force with df, and then several dm mass will be there and all their mass will attract. So total force on this point mass due to this continuous complete mass, total mass, will be sum of this df. All df will be added. That means we are integrating df force. So we will integrate this df. The integration of df vector will be give the total force F. So this is a method to calculate gravitational force between point mass and a continuous mass. Right. So we will discuss it, some question based on this gravitational force. So a question is there that there are say three particles of mass say capital M, small m and small m, and arrangement are given as say in first, second, third and fourth. Capital M, small m, then small m, capital M in between these two small m mass, and then small m, capital M and small m mass are at 90 degree, and then there is some makes an angle, acute angle of joining lines. So we have to find least to greatest force. The three particles, two with mass m, small m, and one with mass capital M, might be arranged in any of the four configurations shown. Rank the configurations according to the magnitude of the gravitational force M, capital M, from least to greatest. So we have to find gravitational force on capital M, least value in which case, and maximum value in which case. So in this case, we see that in first case, the two masses are in same side of small m. So these two forces will be added, and these two forces will be added maximally because angle is say 0 degree. In second case, this small masses are on opposite sides on of m, small capital M, and in same line. So its direction will be 180 degree and its magnitude will be same, so net force will be 0. So we can see that in second case it will be minimum and in first case it will be maximum. So minimum will be second case and maximum will be first case. In third case, forces are making at 90 degree angle and these two forces are equal magnitude, so net force will be say root 2 times g m square by d square. Resultant force. Similarly, in third case, forces are making an acute angle, so resultant will be say 2f cos theta by 2 if angle between these two forces are theta. The resultant will be given by f square plus 2f square cos theta and root, that will say 2f cos theta by 2, and its value will say less than this first. So third value will be say less than. So we see that if angle is say 0 degree, then the force is minimum. Then if the angle is say force is maximum. If the angle is say 180, then force is 0. Then there is some angle is say 90 degree and then some angle is say 60 degree. So in this order, 180 degree angle is say second case, 90 degree angle is say third case, 60 degree angle is say fourth case, and 0 degree angle is say first case. So in this order, we see that first is say maximum force, fourth is say less, and second is the least force. So its answer should be say 2 is least and 1 is say maximum. So 2 force is greater than 3, 3 is greater than 2, and 4 is greater than 3, and 1 is say maximum. So option, we can see that option D is correct. So here option D will be correct. Similarly, we can find gravitational force between point mass capital M and a uniform straight rod of both kept in a straight line with point mass M at a distance D from one end. So here we will take an elementary mass dm. So these are say two rods. So they are say two thin rods, point mass, and this bigger mass rod, and distance between these two are say small d, and this length is say capital L. So first of all, we will choose an elementary mass dm on this uniform rod. So this dm and we will see a force between this dm mass and this capital M. So this capital M point mass and this elementary mass force is for say df, elementary force. So g times capital M then dm upon this distance. So distance between these two are taken as say x. So it will say x square. So this will use the force between these two elementary mass and point mass. So this elementary mass here, it is a point mass. So we can apply Newton's law of gravitation directly. Similarly, other dm mass will be taken over this rod, and all these forces df1, df2, df3, all these forces will be along same direction, that is say towards right, attractive. So all they are in same direction, it will be added. That means say we have to integrate all df. We will put these values of df as say g capital M dm upon x square. So this will be the resultant force. Now we will replace this dm term in terms of say dx. For this we have to use unitary method. For capital L length of this rod, mass is say small m. For unit length of this rod, mass is say m by L. And for dx length of this rod, mass is say m upon L into dx. So this
श्रेया उसको बोलो बंद करना है.
So this dx length mass is say m upon L dx, and this mass is taken as dm here. So dm value will say m upon L dx, and this dm value of dx is replaced here. So it will say g times capital M, m upon L or dx. So this will be integration of say 1 upon x square, that is say x minus 2 integration, and there will be say power rule minus 2 plus 1 minus 1 divided by minus 1. So its value will come out minus 1 upon x. This value comes out minus 1 upon x, integration of 1 upon x square. So this x start here for a d, and at this end last dm will be taken as, and its distance say d plus L. So this x value is from d to d plus L. So this is called say lower limit, and this is say upper limit. Then we will put d values here. So this minus will become plus. So here we will say minus 1 upon plus 1 upon d, and this d plus L here. So d plus L in place of x. So we will put d plus L in x and d as x. So its value will be say d plus L minus d upon say d times d plus L. This L is cancelled out by this L. Its value say gmm by d times d plus L. So this will be the force between these two masses, right? So similar example, we can see that some neutral point between two masses, say 2 kg and 4 kg. So they are say 2 point masses A and B having. So we are taking this as say 2 point bodies, right? A and B. So 2 point masses 2 kg and 4 kg, or say we can taking this as small uniform spheres 2 kg and 4 kg. So distance between centers are say 2 meter between the masses. Where should a mass of 1 kg so should be placed so that the gravitational force on the body due to body A and B is 0. So due to body A and due to body B, net force must be 0. So 2 kg mass will be attractive. That force is say Fa, and for 4 kg mass it will say attractive towards right. So that force is say Fb. So these two forces are opposite, and it should be equal also. So net force on 1 kg mass will be, if these are taking as positive directions, Fa minus Fb, and that will be 0. So this gives say Fa equal to Fb. That means these two forces must be equal in magnitude also. Now this Fa force, this distance is say x, and for Fb distance is say 2 minus x. So this is Fa force g times 2 and 1 divided by x square. Then capital G times 4 and 1 divided by 2 minus x whole square. So these are say cancel out, and 1 upon x square will be 2 upon this 2 minus x whole square. Then we will take this as a square root. So taking square root, 1 by x will be equal to say root 2 by 2 minus x, and solving this 2 minus x and root 2 cross multiplication, this x comes out 2 by root 2 plus 1. Then we will round off it, and so rounding off to it, root 2 minus 1, root 2 minus 1, it will say root 2 plus 1 into root minus and root 2 minus 1 2 times. So this x comes out 2 times root 2 minus 1, that is say 0.83 meter. Root 2 value say 1.414. This will be say value of x. So this should be the distance between 2 point masses 2 kg and 4 kg, where net force is 0, 1 kg mass. Same problem is here. Here two bodies A and B having masses m and 2m respectively are kept at a distance d apart. So these two are kept at a distance d apart. We have to find a point so that the net force on this point mass m dash is 0. So at what distance should be there? So we have to find this x. So m dash we are putting as say x distance, and this m dash and 2m will say at the distance d minus x. The force on this m dash will be say Fm towards left by small m, and we will say F2m by this 2m mass towards right. So again net force on m dash must be 0, that is say Fm minus F2m must be 0. From here these two forces must be equal and opposite. Fm is the force between m and m dash, so it will say g mm dash by distance x square. F2m is the force between m dash and 2m, it will say g 2m m dash upon say d minus x whole square. Then this g is cancel out, m dash is cancel out, and this m is also cancel out, and we will take this as say 1 upon x square divided by equal to say 2 by d minus x whole square. Then we will take this as say square root, it will say root 2 times, this will be x and this will be d minus x, and solving d minus x equal to root 2x, so x comes out d by root 2 plus 1. So this should be answer, option A should be correct, right? So this is today's lecture, class 1 of this gravitational. We will discuss remaining part lecture in next day, right? Thank you. Thanks.